Chapter 3, Equations and Inequalities. So, our learning intention is to solve problems involving quadratics. You are going to be able to identify a set of solutions for linear equations, solve simultaneous equations using the elimination method and the substitution method, and solve simultaneous equations graphically to find regions that satisfy inequalities. These are the key skills. And then obviously the abstract is where we're going to get our people with the A's, where we are looking at different methods. How do we know that we can use a discriminant? Okay, and we're going to make sure that we can focus on everything in Pure 1. Okay, so new since GCSE, okay, is solving inequalities and sketching them on a diagram. Okay. Simultaneous equations using graphs is a little new. We did a few, but not with quadratics. And sketching inequalities we did at GCSE. Okay, so two new things that are extending onto what we already know. So, we have different types of solutions, okay, for quadratic equations. Now, we need to understand the different types that we have. For example, if we were to, not quadratics, just these ones. If we were to solve this, 2x plus 1 equals 5. We're going to get x equals 2. Okay? We're going to get a single value. There is only one value of x that would satisfy this equation. For the second one, if we were to solve this, we're going to get x plus 2, x plus 1. So x could equal minus 2 or x could equal minus 1. We've got more than one value, which would make this true. And just to remind you, when we're solving this, what this actually means is this x is minus 2. If I put minus 2 in here, plus 3 lots of minus 2 plus 2, I'm going to get 0. That's what it means when we solve this. Same if I put minus 1 in here, squared, plus 3 lots of minus 1 plus 2, I will get the answer 0. That's what we're actually doing when we're finding x. When is this true? When does the equation equal 0? For the next one, x is larger than 3. Okay, so x could be 4. X could be 126. X could be 3.1. X could be 2 billion. It can be an infinite amount of numbers. It doesn't have to be an integer. Okay? It can be a decimal. The next one, x squared equals minus 1. That would mean that x equals the square root of minus 1, plus or minus, Faisal. Okay? And we are going to reject that because it's not real. Okay? No real solutions. It's going to give us an imaginary number, which again, we don't need to worry about. And then for this one, x squared plus x, if I was to factorise that, I am going to get x plus 1. It's the same on both sides. It doesn't matter what value I put in, does it? Every single value, because the left-hand side equals the right-hand side, whatever I choose will always be the right-hand side. It's the same thing. Okay? So, these are the types of solutions that we could have to some equations, and these are called solution sets. We need to understand that solutions is really important, what we're looking for. So, for example, different types of solution sets. A single solution. So if I had x plus y equals 9 and x minus y equals 1. Okay? There's only one way you could make this. Is there or not? X, a number plus a number is 9 and a number take away number is 9. So we could have x equals 5 and y equals 4. Is that the only way to make this? No? How else could we make it? 7 and 2? What's 7 take away 2? Yep, not 1, is it? Okay? So this is going to give us a single solution. Right, two solutions. We could have x squared plus y squared equals 10 and x plus y equals 4. When I put this in, I'm going to have two solutions for x, which is going to give me, in turn, a solution for y each. Something that has no solutions is going to be an equation, for example, x plus y equals 1 and x plus y equals 3. That's not possible. Two numbers added together cannot give me 1 and also add to give me 3, can they? It's going to give me no real solutions. And then something that's going to give me an infinitely large set of solutions is essentially the same equation. For example, x plus y equals 1 and 2x plus 2y equals 2. I've just doubled the equation. But the solutions are still going to be the same, okay, and infinite. So when we're looking at simultaneous equations, make sure that, sometimes you look at them and think, oh, can it be solved, can it not be? Am I going to have no solutions? Right, and you'll be able to say that. So, recap. Now, I'm hoping I really don't have to go over simultaneous equations too much, but we will do a recap. Okay, we start off, we choose, do we want to have the x's the same or the y's the same? Y's. So then we're going to multiply, this one's minus 3y, I want this one to be the same, so I'm going to multiply the whole equation by minus 3. So I'm going to get minus 9x minus 3y equals negative 24. Okay, then I've got 2x minus 3y equals 9. Now I want to eliminate the 3y's, so minus 3y minus 3y is going to give me 0, isn't it? Okay, so I'm going to get minus 9 minus 2x is minus 11x. Minus 3y minus 3y is 0. Minus 24 minus 9 is minus 33. So then I'm going to divide both sides by minus 11. So I'm going to get x equals minus 33 over minus 11. X equals 3. I'm now going to substitute x back into, I'm going to put it into this equation here. So I'm going to get 3 lots of 3 plus y equals 8. So I'm going to get 9 plus y equals 8. So y equals 8 minus 9, which is minus 1. So I've got my two solutions. Everybody should be confident doing that. If you're not, I'm not teaching this. This is GCSE prior knowledge, okay? Next. If you have forgotten, obviously I can give you a quick hand, but you need to know this, yeah? Next, x plus 2y equals 3, x squared plus 3xy equals 10. Okay, this is going to be by substitution. We can't use elimination. Okay, we can only use elimination because we are multiplying by an integer here. When we multiply by an integer, it doesn't really change the equation that much. Okay? But here, to get them the same, we'd have to multiply by x. We cannot multiply by x because x is a function. You cannot multiply by a function. You're multiplying by something unknown. Okay? It could change the whole thing, so we can't do that. So we're going to use substitution. So the first equation I'm going to rearrange to get x equals 3 minus 2y. Then I'm going to substitute that into the second equation, so x squared. So I'm going to put 3 minus 2y squared. And you can see every time I substitute, I use brackets. And you will also use brackets. Plus 3 lots of 3 minus 2y lots of y equals 10. So I'm going to get 4y squared minus 12y plus 9. Okay, again, I've literally expanded that in my head. Okay, but we should all be comfortable with 3 minus 2y squared equals 3 minus 2y, 3 minus 2y, okay? But you know, I'm doing it in my head. Then I'm going to do 3y times both of these, okay? So I'm going to get plus 9y minus 6y squared equals 10. Okay, again, I'm doing multiplying in my head because that's something that you should be able to do. Now I'm going to collect like terms, so I'm going to get minus 2y squared minus 3y plus 9 equals 10. I'm I really don't want to deal with a negative y, so I'm just going to put everything to the other side. So I'm going to get 2y squared plus 3y minus 9 equals minus 10. Okay? I'm then going to have 2y squared plus 3y. I'm going to add 10 to both sides, plus 1 equals 0. Now that I have that, I can factorize. So I'm going to get 2y plus 1, y plus 1 equals 0. So I'm going to get y equals negative a half, or y equals negative 1. Now that I have my values for y, I'm going to substitute them back into my rearranged equation. So x equals 3 minus 2 lots of minus a half, which is x equals 4. And then I'm going to get x equals 3 minus 2 lots of minus 1, so x equals 5. Once I've done that, I need to really be clear exactly what's going on. Now I'm just going to highlight it so you can see when y is minus a half, x is 4. When y is minus 1, x equals 5. But it really needs to be clear which one's related to which one. Okay? And that's because when we do some questions, we will need to know. Here is a quadratic simultaneous equations. Off you go. So, nice and easy question. They've actually already rearranged one of the equations for you. So you can substitute in y equals x plus 1 straight into here. Now, when we're substituting... Oh, sorry, everyone. Okay, when we're substituting, we're going to have 3x squared plus y, but y we've written as x plus 1. X plus 1 squared equals 21, because I'm substituting. So I'm going to get 3x squared. Now x plus 1 squared is going to give me x squared plus 2x plus 2. And that's going to equal 21. 3x squared plus x squared is 4x squared plus 2x. And then 2 minus 21 is minus 19 equals 0. Is that right? Well, oh, plus 1. What an absolute silly mistake to make. Sorry, everyone. Go back. Okay, here we go. Plus 1 equals 21. So then I'm going to have 4x squared plus 2x. 1 minus 21 is minus 20. There we go. That's better. So now I'm going to... What am I going to have? 4x and x. Well, I suppose I could divide everything by 2, actually. 2x and x minus 10 is 5 and 2. Plus 5? No. Plus 5 minus 2? Minus 1. No. Minus 2. What did we get? X equals 5. I've done this completely wrong. Right, so this one is x plus 5, x minus 2. Oh, yep. So now I'm going to get x equals minus 5 over 2 and x equals 2. I'm going to substitute that back into y equals x plus 1. So here I'm going to have y equals minus 5 over 2 plus 1. So y equals minus 3 over 2. And then here I'm going to have y equals 2 plus 1. So y equals 3. And remember, please can we make sure it's clear which values of our x and y are paired together. Okay? Now, if you're happy with that, please can you do some questions from here? Again, I really don't think we need to spend a lot of time on this. This is just a recap from GCSE. Okay, here we go. Answers are on the next page. Double check it's correct. If you're correct, then great. So the whole point of that conversation was because what we're going to do right now is we are going to solve simultaneous equations graphically. Now you have to be able to draw these graphs on paper. But what we're going to do for the rest of the 20 minutes is get a bit of an understanding of how to use Desmos and how to ensure that when we are drawing these on paper, that we can double check our answers. So, just like if we want to know the solutions of two simultaneous equations, we could draw both lines and wherever they crossed would be the solution. It is exactly the same with a quadratic. So here we go. We're going to draw this. If you don't know how to draw the graphs, I will show you. But existing photo. Okay, if you don't know how to draw the graphs, I will show you. But you should know how to draw these graphs, okay? You should know how to draw a straight line. You should know how to draw a quadratic. Drawing's not important today, okay? What's important right now, we'll do drawing tomorrow. What's important right now is where they cross. Okay, so pretend we've drawn the graph, tick. Okay, now the reason why we're going to use Desmos as well is because once you draw your graph, you can check it's correct yourself using Desmos. Then it says, use your graph to write down the solutions to the simultaneous equations. This is where they cross. So I've got one solution here, I've got one here. So if I look at the first one, okay, my coordinate, this is -1, 5. And then for my second coordinate, I have 2, -1. Perfect. So that means x equals -1 or 2 and y equals 5 or -1. So what algebraic method, perhaps thinking about the previous chapter, could you have used to show the graphs would have intersected twice? Because in the question it will say prove or show that the graph intersects twice. If it intersects twice, okay, how could we show that it intersects twice?
Put the first equation equal to the second equation and then just find the values of x and y?
Yeah, you can, exactly. You can put the first equation into the second equation. You can substitute in, so 2x plus and then x squared minus 3x plus 1. Okay, so it is simultaneous equations and elimination. Well, this, if they intersect twice, if we did use simultaneous equations, so 2x plus, and instead of writing y, we're going to write our x squared minus 3x plus 1 equals 3. We're going to say that this has got our solution set contains two solutions. Okay? Because that would mean that it intersects twice. And you'd solve that. Okay? Oh, I didn't record that. Okay. So, if it has two solutions, we know that b squared minus 4ac is greater than 0. If I substitute it in, I get 9 is greater than 0. So therefore, there's two real solutions. This only works with simultaneous equations once you've substituted in, okay? Because then that's how we see that combined, if they have solutions or not. So, what you're going to do for me is you are going to draw the graph of y equals 2x minus 2 and y equals x squared plus 4x plus 1. And then you're going to prove algebraically that the lines never meet. Okay? So to prove algebraically that they never meet, you're going to use simultaneous equations and we're not going to get a set of solutions. Okay? And do you remember we were talking about solution sets? Whereas on this one here, if the lines never meet, our solution set contains no solutions. And you'll find that when you substitute this in, so if you get y equals 2x minus 2, instead of writing y again, I'm going to write minus 2x minus 2 equals x squared plus 4x plus 1. You solve that, and then you'd show there'd be no solutions. You reject. I want you to, so for this one now, if we drew the graph, we're going to get, now I'm actually going to sketch the graph for you, but I'm going to do the sketch as accurate as I can, okay? So here we go. We have x and y. 2x minus 2, it crosses at minus 2. And for every one along, we go up 2, because my gradient, so it's going to go here. This is my line, y equals 2x minus 2. Then I've got x squared plus 4x plus 1. Now, this doesn't actually have any real roots, okay? But I can complete the square. So I'm going to get x plus 2 squared. Minus 4 plus 1 is minus 3. So I'm going to get minus 2 minus 3. So if I look, minus 2 is here. Minus 3 is here. Oh, no, that doesn't make any sense. I'm just going to cross at 1. Oh, it must have real solutions then. Okay, so if we put that into our calculator, 141, what is the answer? For minus 2 plus or minus root 3. Okay, so then this graph is going to look like this. Okay, this crosses at 1. This here is going to be minus 2, minus root 3, and this is going to be minus 2 plus root 3. As you can see, they do not intersect, okay? And you would have proper graph paper to put all these points and then draw your graph, okay? They do not intersect. There we go. So, we draw a graph, again, double check on Desmos, all the key points, and this needs to be completely accurate, so you need to have, this is then, you need to write, you know, your graph is going to have an axis 2, 3, but I'll print these off for you, okay, so you don't have to do that. Then for this one, we'd have x squared minus 2x plus 3 equals 0. Okay, if we put that into our calculator, what do we get? 1 minus 2 and 3.
What's it called? Imaginary?
Yeah. Okay, now I've completely forgotten what we... Oh, it doesn't say. We have to write a specific sentence here. Okay, so no solutions. Okay, this is giving us no solutions, or, you know, no solutions, therefore they do not intersect. Okay, perfect. Like in this question, if the lines never meet, that means they have no solutions. So b squared minus 4ac will be less than 0. So here we're going to have minus 2 squared minus 4 lots of 1 lots of 3. So we're going to get 4 minus 12 is less than 0. Okay, because we're substituting them in. So we can choose, pick and choose how we use. Actually, right. Okay, last example. Okay, I'm just going to do this at the front on my own and see how far we get. So the line with the equation y equals 2x plus 1 meets the curve with equation kx squared plus 2y plus k minus 2 equals 0 at exactly 1 point. Given that k is a positive constant, find the value of k. Okay, so we can use substitution, and instead of using y, we can substitute in 2x plus 1. So we're going to have kx squared plus 2 lots of 2x plus 1 plus k minus 2 equals 0. So kx squared plus 4x plus 2 plus k minus 2 equals 0. So kx squared plus 4x plus k equals 0. Now, because we've substituted it in and we're saying that it has one solution, if something has one solution, has one root, this is where we use what we just used before. If something has one solution, one root, b squared minus 4ac equals 0, and that's how we can then use that to find our k. So if we continue with this, our b in this case is 4. So we can get 4 squared minus 4 lots of a, which is k, lots of c, which is in fact k. So we're going to get 16 minus 4k squared equals 0. Okay, 16 minus 4k squared is actually the difference of two squares. And that's going to give me 4 minus 2k, 4 plus 2k. Is that right? Oh no, sorry everyone. I've gone wrong, haven't I? If it has one solution, oh yeah, equals 0. Oh yeah, that's fine. So then I'm going to get k equals 4 minus 2k. I get k equals a half. And k equals minus 2. No, that's not right. Plus 2. So k equals 2 or k equals minus 2. For this value of k, find the coordinates of this point of intersection. Okay. Now, we've got two k's, but we need to read the question. It says that k is a positive constant. So the only k we're going to accept is this one. This is the k that we would then use in the second part. So we have y equals 2x plus 1. And we have k, which is 2. So for the second, we're going to have 2x squared plus 2y, and then 2 minus 2, I'm just going to put 2 minus 2 is 0, equals 0. But that's going to cancel, isn't it? I substitute it back in. So y equals 2x plus 1, and then we're going to get 2x squared plus 2y equals 0. Substitute this one into here. Going to get 2x squared plus 2 lots of 2x plus 1. So I'm going to get 2x squared plus 4x plus 2 equals 0. That's going to give me x squared plus, so I'm just going to get x plus 1 squared. So this means that x equals minus 1. For x to equal minus 1, we can find out what y is by substituting in. Y equals 2 lots of minus 1 plus 1, which is going to equal y equals minus 1. So our point of intersection, is x equals minus 1, x equals plus 1. Okay, so recapping inequalities, this is going to help us with the discriminant questions, okay? So, very quickly, we are just going to go through these questions. We should be confident with these. So, if 2x plus 1 is greater than 5, we're then going to have 2x is greater than 4, and that means that x is greater than 2. Nice and easy. Then on the second one, if we expand both sides, I'm going to get 3x minus 15 is greater than or equal to 5 lots of minus 2x plus 16. Okay, now I am going to do this in my head. So I'm going to move the 2x to the left-hand side to get 5x is greater than 5 plus 16 is 21. 21 plus 15 is 35. I'm going to divide both sides by 5, so x is greater than or equal to 7. And then I have minus x is greater than or equal to 2. Now, to get x on its own, I have to divide by a minus. If I ever divide by a minus, I have to flip the sign. So x is less than or equal to minus 2. Sorry, everyone. 21 plus 15 is 36. So then we're going to get x is less than 36 over 5, which is 7.2. X is greater than or equal to 7.2. Okay, then for the next one, we have x is less than 3 and 2 is less than or equal to x, which is less than 4. If we combine them, if we think about it, I'm just going to draw this on a number line just to show us. Okay, we have 1, 2, 3, 4, 5. If we think about the x is less than 3. So we have less than 3, right? But then we have x is greater than or equal to 2, but less than 4. If I combined them, I have to see where they overlap. And they only overlap in this part here. So my new inequality is going to be 2 is less than or equal to x, which is less than 3. Okay, because we have to see where they overlap, because it needs to satisfy both. Okay, the other way you could look at it is, if you think of all the numbers that we could have here, we could have 2 or 3, okay, because we can't have 4. And now it has to be less than 3, so really we can only have the number 2. Or anything less than 3, because we could have 2.5. So, we're just going to do a quick practice. Please can you find the set of values for which these occur. If you're not very confident, go for green. If you are confident, orange. And then if you're really confident, which is really the level we should be at, it should be the pink, because this is using 2 sets of inequalities and where they both do it. I'm going to give you 5 minutes. If you divide or multiply by a negative, you need to change the sign. Okay? Okay, so 2e, I've got 1 plus 22 minus 11x is less than 10x minus 40. Right, so I'm going to get 23 minus 11x is less than 10x minus 40. Then I could have 43 is less than 21x. Then I'm going to have 43 over 21 is less than x. What's 43 over 21? Okay. Okay, this is supposed to be 63. So we're going to get 63 over 21, which is 3, is less than x, or x is greater than 3. Okay, so solving quadratic inequalities. Here we go. Nice and easy. So, x squared plus 2x minus 15 is greater than 0. When we have greater than 0 or less than 0 or equals 0, you know, this is where this is going to help us with our discriminant homework, because we know if it has 2 real roots, is greater than 0. We know if it has one root or equal roots, it's equals 0. And we know if it has no real solutions, it's less than 0. So when we're doing these questions, what I'm about to teach you now is going to help us with the answers. Okay. So normally, whenever we're doing these questions, we will end up with a quadratic of some sort, won't we? And we'll have greater than 0, less than 0, or equal to 0. So it doesn't matter what our quadratic is. Here we have an example of a quadratic. X squared plus 2x minus 15 is greater than 0. Please forget about the greater than 0 for the time being. Okay? Let's just focus. We have to solve a quadratic. So we need to solve this. So to solve it, I can either put it into my calculator or I can factorise. I'm going to factorise. So I'm going to get x plus 5 and x minus 3. This has to be greater than 0. Okay? So I'm going to get x equals minus 5 and x equals 3. Those two solutions essentially have to be greater than 0. So what this means is, how do I write those solutions greater than 0? Normally, when we have an equation, okay, it's y equals x squared plus 2x minus 15. So essentially, we want to know, where is y greater than 0 for these values? Okay? Now, when we have an axis, y is always positive here, isn't it? So wherever the curve is on the positive side, because we want greater than 0, we want wherever the curve is in the top two quadrants, okay, in these here, because all of this is where y is positive. Anything below the x-axis is where y is negative, and it's told us y needs to be greater than 0. That means we need y to be positive. So we need y to be above the x-axis. So that when we look at this curve, the only way y is above the x-axis is this part of the line here and this part of the line here. The only way this happens, and if we have a look, if we just think of a point, okay, x is going to be 3, or x is going to be 4, or 5, or 6, or 7, yeah? So that means x has to be greater than 3. And if we have a look at the graph here, where is y positive? Well, that's when x is essentially less than minus 5, isn't it? So now I have two inequalities. X has to be greater than 3, or x has to be less than minus 5, because that is the only way where y is positive, and we want the equation to be positive. Okay? Now, there is a trick to remember this, okay, which you can use, but really we need to understand what's going on. So, I'm going to show you another one where it's less than or equal to, okay? So we want less than. Again, we have the same equation. So if we sketch the region, okay, we know it's going to pass at minus 5. So this is 3, and this is minus 5. Okay, and we want where the equation is less than 0. Now, normally when we have an equation, we do write y. So we want where y is less than 0. Where y is less than 0 is below the x-axis. So we want anything below the x-axis, which is part of our line. So if we have a look at our line here, where is it below the x-axis? Actually, it's this part, isn't it? So it's below the x-axis here. So that means that we could have any number, essentially, in between minus 5 and 3. So our set of solutions is actually minus 5 is less than or equal to x, which is less than or equal to 3. Okay? And that is our solution. Now, because it says less than or equal to, I have less than or equal to. If it just said less than, I would have less than and less than. So, there is a trick if you want to remember the trick. Okay? This only works, the trick only works for a positive curve. So it only works for a U curve. There's a different trick for an n curve, okay, which is a negative quadratic. So the trick is, if it's less than or equal to 0, in your solutions, you will have x is in between two values. If it's greater than or equal to 0, in your solution, you'll have one value is less than or equal to x, and one value, x needs to be greater. Sorry, I've written this the wrong way around. X needs to be less than a value, or x needs to be greater than a value. Okay? So that is the trick. But really, we need to have understanding of what's going on. So, here are two more examples. Step 1. Solve x squared plus 5x is greater than or equal to minus 4. I need to put it equal to 0. So we're going to have x squared plus 5x plus 4 is greater than or equal to 0. I now need to solve this. So I'm going to get x plus 1, x plus 4. So that means x equals minus 1 and x equals minus 4. Now if I draw my graph, it's going to be here. Now this is going to be minus 1, this one is minus 4, and it's going to cross the y-axis at 4. Now if I read the equation, it wants it greater than or equal to 0. So where is this greater than 0? It's on this line and this line, because it's greater than 0. We want the positive values of y. And y is only positive above the line of the x-axis. So if you think, you have x and y here, yeah? Normally, these values are 1, 2. These ones are minus 1, minus 2. Y is only positive above the x-axis here. That's when y is positive, isn't it? So now, I need to have two inequalities, because it's positive all up here, and all up here. Now remember, we want less than minus 4. So x is less than or equal to minus 4, or x is greater than or equal to minus 1, because we want it to be greater than or equal to minus 1, or less than or equal to minus 4. For the second equation, we want where x squared is less than 9. So I'm going to have x... Oh, sorry, before I actually continue, did anyone have any questions? Okay, second one. So we're going to have x squared minus 9 is less than 0. X squared minus 9. The first thing we should be thinking of is difference of two squares. So we're going to get x plus 3, x minus 3. Again, if you're struggling with factorising, you've got a calculator to do this. X equals minus 3 and x equals plus 3. And even though it's nice for you to use a calculator, we need to learn this. But for now, just use your calculator. So then, we're going to draw this out, x and y, and we're going to get minus 3 and plus 3. Okay? And it's going to cross here at minus 9. Now, it wants less than 0, so we want below the x-axis. If it wants less than, we want below. Okay, so anything below the x-axis. But where is our graph? Where is our graph below the x-axis? Here is our graph, and it's in between 3 and minus 3. So that means our answer is minus 3 is less than x is less than 3. And that is our final answer. You have 2 questions to do that have been on previous exam papers. Please, can you do that now? Okay then, so question 1. We need to expand the bracket, so we're going to get 3x minus 6 is less than 8 minus 2x. I'm going to move all the x's on one side, numbers on the other side, so I'm going to get 5x is less than 14. So x is less than 14 over 5. Is that right?
Yeah.
Perfect. Number 2. Great. They've already factorised it for us. So this is less than 0. So 2x minus 7, and I'm going to write x plus 1, is less than 0. If it's less than 0, we want below the line, okay? So x is going to equal 7 over 2, and x equals minus 1. And if you think about it, 7 over 2 and minus 1, the graph's going to look like this. We want below the line, so it's going to be 1 inequality. So it's going to be minus 1 is less than x, which is less than 7 over 2. Some of you might have put 3.5. That's okay. Then the next one says, okay, it needs to satisfy both of them. Now, we've already done a lot of the hard work in the first questions. 14 divided by 5 is, in fact, 2.8. So if you were to look at this, x has got to be less than 2.8, but x has to be in between minus 1 and 3.5. Well, if it has to be less than 2.8, we can just cross that one off, and now it's minus 1 is less than x is less than 2.8. Or I'm happy for you to write minus 1 is less than x is less than 14 over 5. Personally, I would always write a fraction, but the decimal, convert to decimal to really understand what's going on. So that is a total of 6 marks. How many marks did you get out of 6? Okay, so if we're going to draw it, okay, if we had a number line, this is 0, and this is 4, this is 3, this is 2, and this is 1, okay, it's my number line. If I was to draw this now, x is less than 2.8. 2.8 is roughly here, isn't it? And it's less than, okay, so this is 2.8, okay? Then, it says x is between, oh, sorry everyone, this is minus 1, this is minus 2. Then it says x is between minus 1, which is here, and 3.5, which is here. This is 3.5, yeah? Where do they overlap? Well, actually, they overlap on this part. Okay, so it has to be less than 2.8. 3.5 is out the window now. Think about it this way. You have a number has to be less than 3.5, and it has to be less than 2.8. Well, there's no point saying the number has to be less than 3.5 then, because if it has to be less than 3.5 and less than 2.8, well, it just has to be less than 2.8. It's a ridiculous notion. All right? That's what we're trying to do. If you want to draw the picture, you can, but think about it logical. What's actually going on? Given that the equation 2qx squared plus qx minus 1 equals 0, where q is a constant, has no real roots. So that means our discriminant is less than 0. Amazing. It says show that. Okay, so remember, we always write our A equals 2q, our B equals q, and our C equals minus 1. You have to write that. No two ways about it. You need to write this down.
Really?
Yes.
Why?
Because I said so, Faisal.
This is right. Why does it matter?
But it's the example.
Because it matters to me. Right. You want to get the mark, you write it down. So now we're going to do B squared. So q squared minus 4 lots of A bracket C. If you don't write this down, you definitely have to write this down.
Okay, I did that.
Right. Then that's going to be 2q squared plus 8q is less than 0. Oh, and by the way, you have to write b squared minus 4ac is less than 0, therefore no real roots. You have to state that that's the equation you're using in y. Okay? So, that's part 1, 2 marks, nice and neat. Hence, find the set of possible values of q. So if I have q squared plus an 8q, I've got no constant at the end, I can just factorise out q. So q lots of q plus 8 is less than 0. Now remember, if I look at a graph, this is a positive. If I'm looking at less than 0, I'm looking below the axes, which means I'm going to have one inequality, because it's going to be in between two numbers, isn't it? So that means that q either equals 0 or q equals minus 8. So that means my graph's completely wrong, because it should look like this. Okay, so it's going to be 0 is less than x is less than minus 8. So sorry everyone. This is q. Absolutely correct. Minus 8 is less than x, which is less than 0. Please do not make that absolutely ridiculous mistake I've just made. I can't believe that. That's embarrassing. Okay, please make sure the smallest number is on the left-hand side, okay? And then give yourself ticks. That's 3 marks. Wait there, everyone. I've done a mistake again. Please make sure you write q. The question is saying for q. It's so easy. So easy to write x. It does say the values of q. Okay, so when we have an inequality that is a division by an x, we cannot just multiply x by both sides. It doesn't work like that because we're multiplying technically by an unknown function. Okay? And if you think about, if we had, for example, 6 over x equals 2, okay? Well then, this means 6 over x minus 2 equals 0. Okay, let's just pretend that's y. Yeah? That graph, I have no idea what it's going to look like. But, sorry, so, yeah, so I know that 6 over x equals 2, 6 over x minus 2, the graph's going to look something like this. If I multiply both sides by x, I'm going to get 6 equals 2x, and 2x minus 6 equals 0, okay? If I was to draw that as a graph, well, 2x minus 6 is actually, in fact, a straight line. It's going to cross at minus 6, it's going to have a gradient. Oh my. Here we go. So it's going to look like this, okay? And this is going to cross at minus 6. Now, they're two completely different graphs. We can't do this. It's ridiculous, okay? They don't even mean the same thing, do they? Okay, so we cannot multiply by an x. That's not what's going to happen. So, what we need to do is, what's going to happen? It tells us x cannot equal 0, because obviously 6 over 0, we're not going to have 6 divided by nothing, okay? So what can we do? So as we know, the reason why we couldn't multiply by x is as well, because x could be a negative, and if we multiply by a negative, we're going to change the sign, aren't we? But what number of x do we know will always be positive? And that number is x squared. Okay? So if you just had 6 over x is greater than 2, if you multiplied everything by x squared, you're going to get 6x squared over x is greater than 2x squared. Okay? This is going to cancel to leave you 6x is greater than 2x squared. We can rearrange this to get 2x squared minus 6x is less than 0. I can then do 2 lots of x bracket x minus 6 is less than 0. You're completely right. It's minus 3 is less than 0. So we're going to have two solutions. X can equal 0 or x can equal positive 3. Now, as we know, if we're looking for less than 0, We're looking below, we're looking in the negative y range. So that means my inequality is going to be 0 is less than x is less than 3. Now, Guider had a question on, I'm just going to put this up here. Guider had a question from the textbook yesterday that had 8 over x squared plus 1, I'm just going to say is less than 9 over x. Okay? So, it was this question, the inequality could have been the other way round, but for now, it doesn't matter. Now, first of all, there's 2 ways we can approach this question. Okay, way 1, which is the way that I would really like us to concentrate on. Okay, remember, I'm just going to call it a something squared plus b something plus c is a quadratic. Everybody should be happy. Something squared plus something plus a constant is a quadratic. We should all be really happy with that. Now, what we have to notice is that something is squared. For this example, if I just rewrite this, and I'm going to move everything to the left-hand side as well. So I'm going to get 8x to the minus 2, because 1 over x squared can be rewritten as x to the minus 2. We should all be very comfortable with that from chapter 1, indices. Then I'm going to have minus, because I've moved this over here, minus 9x to the minus 1, because we should all know 1 over x is x to the minus 1. And then I have plus 1 is less than 0. Let's forget about the less than 0 for now. That doesn't matter right now. But if we have a look, okay, I can rewrite this is 8 lots of x lots of minus 1 squared minus 9 lots of x to the power of minus 1 plus 1. This is a hidden quadratic. We have a function squared plus or minus that function plus a constant. This is a hidden quadratic, and we need to make sure that when we're looking at these types of questions, okay, that we are focusing on the hidden quadratic, okay? So, we could either solve it like a hidden quadratic, so we're going to get, so we could let y equal x to the minus 1, or y equals 1 over x, because x to the minus 1 equals 1 over x. I'm going to use substitution, so I'm actually going to get 8y squared minus 9y plus 1. Okay, I'm going to get 8 y minus 1, and then I'm going to get y minus 1. Okay, so I'm going to get y equals 1 over 8, or y equals 1. We know that y equals 1 over x, so 1 over x equals 1 over 8, so x equals 8, or 1 over x equals 1, which is 1 over 1, so x equals 1. So that's one way to do it. Or, as I've just shown you then, the second way to do it is we multiply by a positive value of x. The only way we can multiply by a positive value is it could be an x squared or x to the power of 4, depending on what we want to try and cancel. In this case, our highest power is x to the minus 2, so we're going to multiply by an x squared. So our original equation, 8 over x squared plus, sorry, I don't know why that went up there. 8 over x squared plus 1 is less than 9 over x. If I multiply that whole thing by x squared, I'm going to get 8x squared over x squared plus 1 times x squared, which is x squared, is less than 9x squared over x. Really sorry, everyone, but... Whoop. Okay, so I know these x squareds are going to cancel. Okay, and this is just going to become 9x. So I'm going to get 8 plus x squared is less than 9x. If I move everything to the left-hand side, x squared minus 9x plus 8 is less than 0. I can factorise to get x minus 8, x minus 1, x equals 8 and x equals 1. Now, if we look at the question above, we've got x equals 8 or x equals 1. Both ways will always work, okay? For any example, they will always work. So just make sure that you watch out for hidden quadratics. They're called hidden quadratics because they're hidden, okay? So you've got to try and find them. So, what we're going to finish off with is inequalities on graph. Now, as we know, when we were working with the discriminant, if we had the equation was greater than 0, we wanted above the line, didn't we? So we'd end up with 2 inequalities above the line where x would be greater than 3 or x would be less than -5. Okay? So we should be completely happy with that. What we are going to do is we're going to incorporate that when we're solving simultaneous equations, essentially, graphically. So if we have a look at the question, L1 has the equation y equals 12 plus 4x, okay? And then we have L2 has the equation y equals x squared. The diagram shows a sketch of L1 and L2 on the same axis. Find the coordinates of P1 and P2. So you can see we've got our x squared is here, okay, and then we have y equals 12x plus 4, and it wants us to find the coordinates of P1 and P2. So where they intersect is where they equal each other. So we're going to have x squared, because that's one equation, equals 12 plus 4x. So I'm going to get x squared minus 4x minus 12 equals 0. I now have a quadratic, which I should be happy factorising or solving. So I'm going to get x minus 6, x plus 2 equals 0. So I'm going to get x equals 6 and x equals -2. Now, that is already on the graph, but this is how we complete that part of the question. Then it says, hence write down the solution to the inequality where 12 plus 4x is greater than x squared. Okay, so we want to know where this line is bigger than the quadratic, okay, which is the curve. So if we have a look, here, the line is under the curve, isn't it? So it's not in that part. Here, the line is above the curve. So that's how we know we want it when it's above the curve. Now, when it's above the curve, here, it's in between two values. So the answer is going to be, if it's in between two values, we're going to have one inequality. Okay, it's going to be less than 6 but greater than -2. If we wanted 12 plus 4x is less than x squared, we want where is the line below the curve, so here's the curve, it's below it, we'd have two inequalities because it'd be this section and this section. Okay? So this is continuing on for the discriminant, which I know we've done a lot of work on. We should be really happy. So this was what we used to do in GCSE, the inequality regions, okay? Nice and easy. The only thing is sometimes they're not straight lines, and we only did them with straight lines at GCSE, okay? So, step 1. It says, draw a sketch. Okay, so remember, we're going to have our axes. Actually, do you know what I'm going to do? I'm going to colour this whole thing in so that we've got a good sketch going on. Okay. Perfect. Okay, so we're going to draw our axes. This is my x, this is my y. Okay, so we've got 2y plus x is less than 14. So that's the equation 2y plus x equals 14. Okay, now, if I was to sketch this, I would always use this trick. When x is 0, if I put my hand over here, x is gone because it's 0, yeah? So 2y equals 14, so y equals 7. So when x is 0, y is 7. x is 0, y is 7. It's roughly here. Okay, this is 0, 7, because it's a sketch. Then I'm going to do the same thing. Oh, when y is 0, x equals 14. So then I know that this is going to be 14, 0. Okay, so my first line is going to be red. And here it goes. Okay, so there's my line. Now it says this has to be, the equation is less than. If it's less than, do we want above or below the line? Below the line. So we're going to sketch, we're going to colour in below the line. There we go. Look at that. Absolutely beautiful. Okay, so that's the part that we want. Incredible. Right then. The next equation I'm going to do in blue is y is greater than or equal to x squared minus 3x minus 4. I'm not going to worry about the y or the greater than for the minute. We're just going to have y equals x squared minus 3x minus 4. So I'm going to get x minus 4, x plus 1, x equals 4, x equals minus 1. And we know it's going to cross the y-intercept at minus 4. We should all be really happy with this. So it's going to go a bit like this. Oh, is that 14? There we go, because this is going to be 4, 0. This here is going to be 0, 0 and negative 4. And this point here is actually minus 1, 0. Okay? Remember, it's a sketch. Okay, perfect. And then it says y is greater than or equal to. So do we want above the curve or below the curve? Above the curve. So essentially we circle inside it. Do we see? Okay. Then it says, what does the question say? Find the region. Great. So the region that satisfies this is in fact the region where they're both shaded, which is in this area here, and I'm going to call that R. So we should be really happy. Y is greater than or equal to minus 4. Well, y equals minus 4 is this straight line here that crosses at 0 and minus 4. We want greater than, so we want above the line, don't we? Nice and simple. We have x is less than 5. So this is the line 5, 0. X is less than 5, so we want on the left-hand side of the line. Then we also have x is greater than 0, so actually it's got to be, pardon? I know. So that's got to be in this bit now. Okay, so it's really, they should have written that as 0 is less than x is less than 5. They shouldn't have given us 2. That's not very nice. And then the last one is y equals 3x plus 2. So I know that's going to cross at 2 here. And for every one along, I'm going at 3. But I want to find where, if it will cross the line x equals 5. Okay, so if I put x equals 5 into here, 3 times 5 is 15, plus 2 is 17. So I know now this is going to be 517. We know that this one is 0, 2. Okay, and it wants less than, so we want below the line. So actually, the complete area is this region here. It's the trapezium. Yeah? Perfect. The only thing I forgot to do is, first of all, if it's less than or equal to, it's solid. If it's not less than or equal to, it's dotted. So please make sure that, you know, this is a dotted line if it's not less than or equal to, okay? It's a silly mistake. So when we do inequalities on a line, you want, it's a solid, if it's less than or equal to, you draw a solid line. If it's just less than, you should draw a dotted line. Okay, because it doesn't include the number. Perfect. Okay, so there are some of these questions. If you are unhappy with inequalities using linear equations, you can do some of the end of the chapter. That is